Have you ever marveled at the magical ability of X-rays to see through various materials? Have you ever wondered how these fascinating images are produced? In this video, we will delve into the captivating process of X-ray production, exploring the generation of X-rays when high-speed electrons bombard a metal target. X-rays are produced when a beam of electrons is accelerated and then strikes a target, typically a metal. As the electrons collide with the target, they slow down, and their kinetic energy is converted into various forms of radiation, including X-rays. This process involves several intricate mechanisms that contribute to the generation of X-rays. One of the primary ways X-rays are produced is through a process called characteristic X-ray production. When high-speed electrons interact with the atoms in a target material, they can cause the electrons in the atoms to transition to higher energy levels. As these electrons drop back down to their original energy levels, they release energy in the form of X-rays. The energy of the emitted X-rays is characteristic of the target material and the specific energy level transitions involved. This process results in the production of discrete or characteristic X-ray lines at specific energies. Another significant mechanism for X-ray production is known as Bremsstrahlung radiation, which means breaking radiation in German. This process occurs when high-energy electrons are decelerated abruptly by the electric field of the target atom's nuclei. During deceleration, these electrons release energy in the form of electromagnetic radiation, which includes X-rays. Bremsstrahlung radiation is characterized by a continuous energy spectrum, meaning that X-rays are produced over a range of energies. This continuous spectrum results from the variable interactions between the incident electrons and the target atoms. Unlike characteristic X-rays, which have specific discrete energies, Bremsstrahlung X-rays have a distribution of energies. The maximum energy of the X-rays produced through Bremsstrahlung radiation is equal to the kinetic energy of the incident electrons. To understand how X-rays are generated when high-speed electrons strike a metal target, let's consider a simple example. When a beam of electrons is directed at a tungsten target, for instance, the following processes occur. The high-speed electrons first interact with the tungsten atoms in the target. Some of these interactions result in the production of characteristic X-rays as the electrons in the tungsten atoms transition to different energy levels and release energy in the form of X-rays. Additionally, the majority of the electrons will undergo Bremsstrahlung radiation as they are decelerated by the tungsten nuclei. These decelerating electrons emit a continuous spectrum of X-rays. The energy of these X-rays ranges from a minimum of 0 up to the kinetic energy of the incident electrons. Now let's look at some key points about X-ray production. In X-ray tubes, the electrons are emitted from a heated cathode. The cathode is typically made of a material such as tungsten or thorium. When heated, these materials release electrons through a process called thermionic emission. The rate of electron emission can be controlled by varying the temperature of the cathode. By applying a high voltage potential difference between the cathode and a metal target, an electric field is established. This electric field accelerates the electrons towards the target. The electrons travel through a vacuum or an inert gas and reach the target at high speed. The target is usually made of a heavy metal such as tungsten or molybdenum. The atoms in the target have tightly bound electrons, making them good absorbers of the kinetic energy of the incident electrons. As the high-speed electrons collide with the target atoms, they slow down, and their kinetic energy is transformed into various forms of radiation, including X-rays. The efficiency of X-ray production depends on the atomic number of the target material. Higher atomic number materials are more efficient at converting the kinetic energy of the electrons into X-rays. So there you have it, a captivating look into the fascinating world of X-ray production. If you enjoyed this video, don't forget to give us a thumbs up and subscribe for more informative content. Thanks for watching.